In this lesson, we'll walk through running the Vehicle Setup Wizard. After completing this lesson, you'll be able to identify your flight controller, calibrate the gyro, calibrate ESCs, and finalize the setup. With the basic overview of LibrePilot, we're now going to take a look at the Vehicle Setup Wizard from the Welcome screen. So you'll get a lot of prompts along the way that tell you exactly what to do. So in most cases, you won't need to follow along with this video. But in case you run into any specific issues with our configuration, I want to make sure that you have this as a resource. So you'll notice the first thing is the big red warning that tells you you must remove all propellers. Now this is a very important step, and I will note that the propellers will not spin unless we hook up an external battery, but just to be safe, it's always a good idea to remove those propellers. Next, it'll ask you about firmware updates. Depending on your flight controller, if you've programmed it at all, we can upgrade the firmware or we can simply skip that step. It'll also go through a board identification process. If you haven't used the software before, it'll have to try to connect and identify what board it is. If you have, it should come up and say USB copter control, which is our CC3D. There are several variations of the CC3D. The preview on the screen shows the full-size CC3D, which is a 36 by 36 board size. We're using the micro CC3D, and that has the same sort of functionality. We still have 6 servo outputs. We have an arrow to tell us what direction the board needs to face, and we have the input from our receiver, as well as some main and flexi ports. We're next going to have to tell it how we're going to configure our input signals. We've talked a little bit about these in some videos in our courses. In this case, we're going to be using PWM, which means that we have one cable per channel. Now that's coming directly from our receiver, the controller that's sending the signal from the ground to the receiver, and the receiver to the flight controller. There are options depending on the receiver and the information that you want to send. We can use a PPM setup, which uses one cable and essentially stacks the signals back to back, so that way you're sending all the signals over one cable. There are also some other options such as S-Bus, using Spectrum, as well as the SRXL, but in our case again we're keeping it very basic so we can understand PWM, one signal, one wire, and that way it's very easy and very straightforward to understand what signals we're sending and where they're going. Next, we need to tell the software exactly what type of vehicle we're designing. A multi-rotor can be 3, 4, 5, 6, 7, 8, multiple blades, multiple motors. We also have the option to do fixed wing, helicopter, or surface vehicles. So once we have determined what our configuration is, our specific configuration is going to be a Quadcopter X, but notice that we can also do a multi-rotor with a quadcopter in the plus orientation, a hex. We can do a hex in the X or H orientation, and then there's also a Y6 orientation. So in our case, a pretty standard configuration for Quadcopter X, and this is important because we need to note the direction that all the motors are spinning. It's very important to make sure that the software can understand what kind of control it has, and the direction of the arrow on our flight controller. When we hit next, we have to determine which ESC refresh rate or hertz rate that we're going to be using. Now we actually have ESCs from DYS that can be anywhere from 50 to 500 hertz. So we're going to be using the 500 hertz option, or really 490 hertz option. Next, there is a connection diagram. If we click on this, it'll open the image. It shows the orientation of the propellers, and it shows you exactly which number and which propeller that goes to. So this can be very handy, especially for the first build or the first time you assemble. You can see that pin 1 on the flight controller, and on our micro CC3D there is a 1 in the plastic housing, goes to prop 1, which is at the top left as we're looking at it. Then prop 2, 3, and 4. So now that we have all this information, we know that we're running a CC3D controller, we're doing a multi-rotor in a Quadcopter X, we're using PWM to send our signals out, and we're using a high or rapid refresh rate ESC. We're going to go to next, and now it needs to calibrate the sensor, and this is the portion where it's very important that our flight controller is sitting level on a level surface, as close as you can get it. Now, if the flight controller happens to be tilted up at 45 or 90 degrees, this is going to affect the way it flies because it's going to try to compensate to keep it level. So keep that in mind that we want to calculate. And while we're doing this, we do not want to touch, shake, or move anything. We want to make sure that the desk or whatever your specific quadcopter is sitting on stays completely level. Once it's done, we can say next. And notice that now we're going in to calibrate our ESCs or our speed controllers. So the first portion tells us again in red, must remove propellers from all motors. So we want to go through each step, confirm all safety questions, press the start button when it becomes enabled, battery not connected. We want to connect the battery to the airframe after it tells us, wait for the calibration beeps, press the stop button, and then wait for them to beep again and disconnect. So here we have to say we removed all propellers, vehicle's not powered by any external source other than USB, and I've read and understand all the instructions above. And notice only then can we press start, and now it tells us to connect a battery. I'm going to connect a single battery in our case and listen for the beep. Once we've heard all the beeps and everything's been configured, we hit stop. Now we can disconnect the battery. And we can go to the next step. Now in the next step, we have to note that we're calibrating the output. Now this means that we're going to be spinning each motor, and we're going to find the point at which each motor begins to spin. And this is important because in general, they'll probably be right around the same number. But if one motor takes a little bit more to start spinning, it's going to be important that we configure it all so they start spinning at the same time to have the most amount of control. So notice that again, we've got some information here, very important. Remove all propellers. They absolutely do not want you to start spinning the propellers and have this thing take off or do any sort of dangerous maneuver in front of you. So you notice that we also have, depending on what vehicle we selected, both motors, controllers, ESCs, and the servos are controlled directly by the flight controller, have to be calibrated. So we're going to hit next. And in this case, in order for us to do this, we're going to have to re-hook up the battery. So the motors are not going to spin until we have external power. So once we have the battery power hooked up, we'll hit start, and we'll start to address the slider and move it until your motor starts to turn in a stable manner. Once we're done with that first one, we can move on to the next one, hit start. And notice that we also have the option to do all four at the same time, but I'm going to do each one manually. I'm also looking to make sure that the correct motor is spinning to ensure that I have the proper connections with my flight controller from each ESC. So now that we have all those configured, we now need to determine which vehicle we want to use. So there are several preloaded vehicles in here. For instance, Racing FPV 260 Hobby King. Now there are some things that we want to make sure that we understand in here. When we take a look at some of these options in here, notice that this one says race, this one says stock, and notice that the difference in some of the options here, 12 amp ESCs, while this one has 12 amp ESCs. We can use current tuning, and you'll notice that this option will use the current tuning settings on the controller. If you haven't configured it before, then you want to go through and pre-configure it. But as we look through here, there are options such as a generic Quad X. There are some other ones. And in general, you want to take a look at what each of these has in terms of options. Notice this one has a 4-cell battery, 18 amp ESCs, specific motor at 2206, which is really close to what our motor is. And the size is 240 to 260. There are also some Hobby King ones in here, And notice again the size, and this one's 320, this one's 250. The max weight on this one is 410, so it's pretty light. And we really want to just go through these options and figure out which one is closest to your build. Now in my case, I'm going to use current tuning, and I'm going to say next. And then we can save this to your, in this case, your flight controller. We'll say save. It'll push all those settings, and then it'll reboot this, and it'll take up to a minute. So at that point, our flight controller is completely set up and configured based on whichever quadcopter design you chose and all your settings. Next thing we want to do is we want to set up our transmitter.